All right, so these are your notes for today. Sorry I couldn't be here in class, sorry. Go ahead and take the notes, follow them, try to get as much as you can, primarily for students that were out of school yesterday, or Friday, sorry. But if you were here on Friday, you should know a lot of this stuff. All right, so start off, this is section 4.2, angles of triangles. So we're gonna be talking about the angles of triangles. What do the angles of a triangle add up to? Now, I think most students will say that they add up to 180 degrees. So that's what I'd make sure I write down, is that the angles of a triangle are going to add up to 180 degrees. This is actually the angle sum theorem. So we're going to write this down. So first thing I'm going to do is draw a picture of a triangle. So if you guys would go ahead in the angle sum theorem box, draw a picture of a triangle, and we're going to call this triangle A, B, and C. And what the angle sum theorem states is that the measurement of angle A plus the measurement of angle B added to the measurement of angle C will have a sum of 180 degrees every single time. This is also known as the interior of these angles, or just the inside of the triangles. Okay? All right. If you need more time to write this down, pause it or go back and rewind it. So next thing, we now need to talk about the exterior angle of a triangle, and this takes us to our next piece. So what is the exterior angle theorem? Now for this one here, I have to draw a very specific type of triangle. So we're going to draw a triangle, but then we're also going to draw a tail on the triangle, and that is going to give us what we call our exterior angle. And what I'm going to do is I'm going to go ahead and number these angles over here. So we're going to call this angle right here, that angle is 1. This guy right here, we're going to angle number 2, and then we're going to go ahead and take this guy and call this guy angle number 3. Now what I'd like you guys to notice is angle 3 is located outside of the triangle. This is what we call an exterior angle. Okay. Now inside the triangle there are 3 interior angles. We have angle 1, 2, and 4. Now the thing is that 4 is next to 3. Angle 4 and 3 are going to add up, so we can write this down. Angle 4 added up, angle 4 added up with angle 3. So if we add that to angle 3, we know that that's going to equal 180 degrees. The reason is it's a linear pair. That's not the exterior angle theorem. What the exterior angle theorem gets to is the idea that if you take angle 1 and 2, angle 1, and you add it, so the measurement of angle 1 added to the measurement of angle 2, this will equal the measurement of angle 4. And this thing is kind of crazy. Not angle 4, the measurement of angle 3. This is a little bizarre, but it kind of makes sense. And the reason I say it kind of makes sense is if you took the 2 red angles and added it to the green angle, you should get 180. Very similar as if you took the green angle and the blue angle, you should get to 180. Therefore, the blue angle 3 should equal the 2 angle 1 and 2 added together. Okay, there is a proof for this, so if you want to go through the proof, we can, but I just want to make sure we understand it. Okay, question number 3. Now, find the measure of each numbered angle. We need to find the measurement of angle 1. Angle 1 is kind of like the blue angle, so I'm going to circle this guy momentarily or point to it. Angle 1 is kind of like the blue angle, and angle 58 degrees, so the 58 degrees and the 78 degrees, you'll notice, are the interior angles that are not touching it. It's not the green angle. The green angle will always touch it, kind of like over here. The green angle was the one touching the exterior. So what we can say here is we can say that if we took the 50, so if we took the 50 degrees and we added it to our 78 degrees, what we should get in turn is the measurement of angle 1. So we'll write down, it equals the measurement of angle 1. So we now know that angle 1 is 128 degrees. The measure of angle 1 is 128 degrees. So we can say 128. Now you'll notice that 1 is on the exterior, but then angle 2, this guy right here, is right next to it. He's right next to it. He's kind of like the 3 and the 4 over here. So what we can say now is that the measurement of angle 2, the measure of angle 2 plus the 128 degrees, so if we add that to the 128 degrees, this right here is what we call a linear pair and should add up to equal 180 degrees. So we can say that those guys are going to add up to equal 180 degrees. All right, so after we do a little bit of the math, what we end up finding out is that the measurement of angle 2 is equal to 52 degrees. So we can say that angle 2 is 52 degrees here. Now, taking a look at this triangle. So now I'm looking at this triangle right here. You'll notice that 2 and 3, some people will say 2 and 3 should add up to equal 128. The problem is that 2 and 3 are not the 2 angles like 1 and 2. And the reason is that 2 is touching 1. So what I'm going to do here is I'm going to look at 2 and 3, and I'm going to say, hey, wait, 2 and 3 are kind of like the red angles. 2 and 3 are kind of like the red angles for the 120. So this guy here and this guy here behave like the red angles 1 and 2 for the blue 3 that's on the outside. So the 120 is going to behave like the blue angle right there. So what I can now say is that angle 2 plus angle 3 are going to add up to equal 120. But 2 we know is 52 degrees, so I'm going to write 52 degrees plus the measurement of angle 3 is equal to the 120 that's on the outside. So I'll go ahead and change that to blue, is equal to the 120 that's on the outside of the angle. And now I can just solve the problem. We now have that the measurement of angle 3 is equal to 68 degrees. 68 degrees. So we now know that this guy is 68 degrees. Now, since 120 and 4 are next to each other, we can also say that the 120 and the 4 are going to add up to equal 180 because they're a linear pair. So we can say the 120, which is on the the 4, so we'll say the measurement of angle 4, which is on the inside of the triangle, added to the 120, which is on the outside of the triangle. So if we add that to the 120 on the outside of the triangle, should add up to a total of 180 degrees because they're a linear pair. So now we can solve this. This will give us that the measurement of angle 4 is equal to 60 degrees. So I now know that this guy is 60 degrees. All right, now you'll notice angle 5, the last angle, the relationship between angle 5 and the two angles on the inside is the same as above. Angle 5 is kind of like the blue angle. It's kind of like that exterior angle. So I'm going to say that the measurement of angle 5, the exterior angle, sorry, I'm at 5, the measurement of angle 5 is equal to, this angle here is equal to these two guys being added together. So the 60, and I'll write this in red because they are representative of the red angles, is equal to the 60 plus 56. So the 60 degrees plus the 56 degrees, which means that the angle 5 is equal to 116 degrees. And we now have the 116 right there. All right. If anything didn't make sense, go back, rewind the video, and watch any specific piece. This is the first video. There's a second video for the back side of the page. If you need any help, come back to class tomorrow, and I'll help you guys fill in those questions. Once